Okay, how you doing, everybody? It's Mr. Massaroni again. We're getting near the end here, doing some similarity proofs on triangles. I've got page 45 in the packet, and we're going to do these two proofs, and then I'm going to do page 46 right after this, so you'll have two separate videos. Okay, so here's our picture, and we've got given AB is perpendicular to BC, and DE is perpendicular to EF. So what I'm going to do is I'm going to draw in our right angles, okay? And then BC is parallel to EF. So I've got BC and EF. And I want to prove AC is to DF as AB is to DE. So I need similar triangles. Okay, now I'm looking and I see BC and EF are parallel. So what I'm going to have here, and I'm just going to mark these angle 1 and angle 2. They're going to be alternate interior angles. Okay, so that's going to give us our AA, and that's going to give us our similar triangle. So now we just have to put the whole proof together here. Okay, so statement number 2 is angle B and angle E are right angles. That comes from the the perpendicular lines. So I can say perpendicular lines form right angles. All right, and then 3, I'm going to say angle B is congruent to angle E, because we know right angles are congruent. So we're all set with that first angle. Now we're going to do what I labeled angle 1 is congruent to angle 2, and I'm putting the whole statement in there when parallel lines are cut by a transversal. That's the line that goes through both of the parallel lines. The alternate interior angles are congruent. Okay, so now we've got our similar triangles, and we're going to line that up. Triangle ABC is similar to triangle DEF, and that's our angle postulate. And then 6, AC is to DF, and this is what we're proving, so this is the last step, equals AB over DE. And the statement is, in similar triangles, corresponding sides are proportional. You've got a proportion, so say that they are proportional. And there is your first proof. Okay, now I'm going to move on to number 2. And what we've got is all they gave us is GE is parallel to DF. And we have to prove EG times EF is similar to ED times EH. Okay, so that's the cross multiplication of our proportion. So I have to get to that proportion. Before I get to the proportion, I have to make sure the triangles are similar. And it looks like I'm going to be using E on both of them, so I'll use a reflexive property at some point. And if these are parallel, I can say that these are corresponding angles. And that's what's going to give me the angle-angle congruence. And what I'm going to do is, I'm going to label angle 1 and angle 2 to make that a little easier for you to see. So angle 1 is congruent to angle 2 when, that's a 2. Sorry about that, a little off my game after the long weekend. When parallel lines are cut by a transversal, the corresponding angles are congruent. Okay? And now we show angle E and angle E. That's our reflexive property. Angle E is congruent to angle E, and that's reflexive property. And now we have similar triangles. Triangle EGH is similar to triangle EDF, and that's angle. Now we put together the proportion. So E is to G as E is to D. It's the same as E is to H. EG is to ED as EH is to EF. Let's say that right. In similar triangles, corresponding sides are proportional. I'm just going to abbreviate here. And then cross multiplying EG times EF equals ED times EH. And all you have to say is cross multiplication. And there you have it. Page 45, all set. Hope everybody's doing okay. Stay safe, stay healthy. Thanks, and good luck.